Greetings to everyone present at the 2020 Sustainable Engineering and Industrial Technology Conference of the Faculty of Engineering, University of Nigeria, Nsukka. I am Engineer Dr. Suoware, and with my co-authors, we're presenting a paper titled Effect of Ammonium Polyphosphate Modified Gum Arabic Powder on the heat release rate of oil palm fiber reinforced polymer composites. This paper will be discussed under the following headings, with emphasis on the results obtained. The background of this paper begins with the application of fiber composite boards. Fiber composite boards can be developed from agro waste such as coal, sugarcane, wood sawdust, oil palm fibers, and their likes. Oil palm fiber contains about 65% cellulose and 40 to 45% of lignin, higher than most choices of natural fiber, which can be used for processing composite boards. The applications of these fiber boards can be found but not limited to the following: ceilings and wall panels, floors, doors, dashboard in automobile. However, the challenges of using the oil palm fiber reinforced polymer composites shows that 65% of cellulose contained in oil palm fiber is responsible for its high heat release rate alongside the resin used. When these fiber boards are exposed to heat atmosphere, it releases combustible volatiles, leading to high heat release rates. How can this challenge be tackled? The high heat release rate can be reduced by the addition of flame retardants during processing. Many researchers suggest that aluminum trihydroxide and ammonium polyphosphate are suitable to achieve a reduced heat release rate. Now, the main objective of this research paper is to evaluate the effects of ammonium polyphosphate modification with gum arabic powder on the heat release rate of oil palm fiber. The materials used for the oil palm fiber composites are as listed as seen. The fabrication process of the oil palm fiber composite began with first treating the oil palm fiber as received with N-azane to remove oil and impurities, and then wash with 5% sodium hydroxide to improve on the compatibility of the resin. It was then sun dried and was ready to use. The panel was obtained by first preparing a mold, and then the internal area of the mold was applied with a release agent, Vaseline, while the ready to use oil palm fiber were then randomly distributed in the mold, ensuring that there were no voids. A paste of resin and the flame retardants, in addition with the catalyst and the accelerator cobalt, were then mixed properly and poured over the oil palm fiber in the mold. This is the final product of the oil palm fiber composites that was obtained after the process. Characterization of the oil palm fiber composites. The heat release rate properties, that is, the contribution to sustained fire, the intensity of fire, and the available heat energy were obtained according to ASTM E1354. Displacement quartz measuring 100 by 100 by 10 mm from the oil palm fiber composite board was tested for the heat release rate components using the cone calorimeter apparatus at the fire laboratory located at the University of Edinburgh, Scotland. The specimen was first weighed and then wrapped in an aluminum foil before placing into a sample holder. Afterwards, on a load cell in the cone calorimeter apparatus. The specimen were exposed in an horizontal orientation of heat flux of 50, 35, and 25 kilowatts per meter squared. The gas analyzer used is the oxygen consumption as preset on the cone calorimeter apparatus surface panel. The process of obtaining the data was repeated multiple times until a sensible result was obtained for the heat release rate components. Results and discussions obtained. In figure 3 shows the effects of heat flux on the contribution of oil palm fiber composite to sustain fire. The graph shows that the addition of the flame retardant reduced the contribution to sustain fire. It also shows that the contribution to sustain fire decreases with increase in heat flux, indicating that the flame retardant was very effective. The flame retardant at 25 kilowatts per meter squared reduced the contribution to sustain fire by 50.1%, exhibiting superior reduction to sustain fire, and suggests that ammonium acid was released during heating, which dehydrated the carbon hydrate present in gum arabic to form a blanketing effect that prevented the escape of combustible volatiles. The result obtained for intensity of fire. In figure 4, it shows that the effect of the heat flux on the intensity of the oil palm fiber composites to fire. The graph shows the intensity of fire decreases with increase in heat flux, similar to the contribution to sustain fire. This is expected as the intensity of fire is a component of the heat release rate. It also confirms the flame retardants could contain the growth of fire. All the studied heat flux exhibited a reduction in intensity of fire, with 25 kilowatts per meter squared heat flux showing the least value. This indicates that the flame retardant interacted with the combustible volatiles released by the oil palm fiber composite to keep the burning intensity very low by oxygen starvation, as shown. As you can see in the picture, this is the burning intensity of the control, which is without the flame retardant, and below it's a picture showing how low the burning is. That is, the combustible volatiles have been reduced and the fire is almost getting extinguished. Available heat energy. In figure 5 shows the effects of the heat release rate on the available heat energy of the oil palm fiber composite. The graph shows an increase in available heat energy. The available energy increased with increase in heat flux. This is expected as heat release rate is a function of time. The thermal decomposition of oil palm fiber composites, the ammonium polyphosphate, and gum arabic could be responsible for the increase in flame energy. The least available heat energy value found at 50 kilowatts per meter squared indicates that the flame retardant thermal decomposition at high heat release rate could slow the heat release rate of the oil palm fiber composites. In conclusion, the flame retardant added to the oil palm fiber reinforced polymer composite reduced the heat release component, that is, the contribution to sustain fire, the intensity to fire, by 37.8% and 40.4% respectively, and increase the available heat energy by 91.3% on the OPFC board. The flame retardants present in the oil palm fiber composite upon dehydration formed a stable charge structure which acted as a barrier to the mass transfer of heat. At 50 kilowatts per meter square, which corresponds to an actual fire scenario. The flame retardant Specie exhibited better flame retardancy that could meet the fire requirements of building applications. We want to acknowledge the persons who have made contributions directly or indirectly. First, the authors would like to appreciate Tertiary Educational Trust Fund, TETFund, Nigeria, through grant approval. The University of Edinburgh, Scotland, for making the cone calorimeter available for conducting the fire test on the oil palm fiber composite board. The African Center of Excellence, ACE-SPED, University of Nigeria, Nsukka, for their support. Thank you, gentlemen, for listening, and God bless you all.